Hello guys, welcome back to our channel The IT Man, and let's solve problem of the day today, subarray with absolute difference less than or equal to the limit. Okay, so let's try to understand what the question is about. So the question here says that we are given an integer array nums and an integer limit, and we have to return the size of the longest subarray in which every element's absolute difference should be less than or equal to the limit given. Okay, cool. Let's try to understand the question now. Let me take this example, and my k is 5. Okay, so what is the subarray possible? Okay, is this subarray possible? No, because the difference is more than 5. Okay, now we need to take this out of context. Now let's try from this. Okay, is this subarray possible? Yes. Is this subarray possible? Yes. Is this subarray possible? No, because 7 minus 1 becomes 6. We need to take this also out of the picture. Let's start from here. Is this subarray possible? Yes. Is this subarray possible? Yes. Is this subarray possible? Yes. So what's the length? 4. So here we saw that the maximum subarray length which we found was 4, right? So this becomes our answer. I hope the problem statement was clear. So here, did you notice something? What we did? We did a sliding window approach, right? We slided over the array. We checked that, okay, what was the maximum we could achieve? If not, if the condition was violated, we started ignoring the last elements and we moved from there forward. So hence, of course, now I think everybody can understand this is a sliding window problem. Okay, and one more thing to notice here, how we kept track of the absolute maximum difference. We took the maximum value we could find in the subarray and the minimum value we could find in the subarray. Now, okay, understand this. Let's say in this subarray 2472, okay, in this subarray, how can you ensure that the difference between any two numbers would be less than k? The idea is simple. Let's just take the minimum value and the maximum value. Okay, so whatever the difference between the minimum and the maximum value comes, okay, I can tell surely that there can exist no such combination in this subarray which will exceed this number. Correct? I hope I make sense. Okay, cool. So let's try to solve this problem using these 2 points. Okay, let me write the array here again. Okay, 10 1 2 4 7 and 2, and my k is 5. Cool. Now in the sliding window approach, what we do, we take 2 pointers, right? I and j. Here we also need to keep track of the maximum and the minimum elements, right, in the subarray. How we can do that? Let's maintain q. Okay, let's maintain a q. So what I'll do is I'll maintain a queue called as increasing queue, and I'll maintain a queue called as decreasing queue. Okay, increasing queue will keep track of the minimum elements, and decreasing queue will keep track of the maximum elements, so that it's very easy for us to just we will take the value, we'll subtract, and we'll find out. Cool. Okay, let's try to dry run our logic. So let's say my I and j both are initially pointing to this element, right? And my minimum and maximum value is 10, right? Because it's we are just currently working on this subarray, a subarray of size 1, right? Okay, so now if I do a minimum minus maximum, uh, okay, let me write it here. So 10 minus 10 is 0, right? And it satisfies our condition. Cool. I'll also keep a track of something called as answer. Let me write it here. Okay, so till now we have found a maximum subarray of size 1. Cool. I'll just keep my I here and I'll move my j here. Okay, so now when I equals to 0 and j equals 1, now what? Now my minimum is 1 and my maximum is 10. Okay, now listen to this part carefully. My maximum is 10, so we will have to keep our increasing queue and decreasing queue in such a way that the 0th position tells us that okay, what was the minimum value and what was the maximum value. Okay, now let's say I have received 1. Okay, and here I need to make sure that this 1 comes before this 10, right? Because 10 is not the minimum in this window of size 2, right? It's not minimum. 1 is the minimum. So what I can do is I can keep on removing all the values. Okay, I can keep on removing all the values which are greater than this minimum value, and once I achieve that state, I'll simply go and write my minimum value here, that is 1. Now understand, okay, why I removed all the values. Think of a solution. Is there a possibility, okay, is there a possibility that this 10 will ever become minimum again? Is there a possibility? Now you might say that what if this 10 reoccurs somewhere ahead in the array? So let's say even if it reoccurs, then there would be this calculation again, right? There would again be this calculation. Now look, once this window we are iterating, let's say this is the window. Okay, let's say this is the window. Now the minimum is 1. If something a bigger value comes, it won't cross this 1 because 1 is the minimum, right? And let's say if something less than 1 comes, so this 1 also has to go, and that will be replaced by some smaller number, correct? So if you think carefully, this 10 won't come into picture in use again. So that's the reason we'll just remove anything which is greater than the current number we are working with, and we'll just keep the smallest number here ahead. Okay, in an increasing order, of course. Okay, cool. I hope I make sense. So now it's 1. So now does this difference, okay, does 10 minus 1 satisfies my limit? No, it doesn't, right? Now what I need to do, I need to increase my I pointer. Okay, I need to increase my I pointer. So what I'll do is I'll simply increase my I to 1. Okay, now my I will become 1 and my j will become 2. Now before moving I pointer, so now we know that okay, this is the subarray which we can't use. Okay, now we have to start our subarray from here, hence we moved I to this position. Now what about this element? Will we use this element again? No, we won't, right? So we'll also discard it from our track of minimum and maximum. Now how to do that? We'll just check if the minimum or maximum, like I mean the q at the 0th position, element in q at 0th position, if anything is equal to this I, we'll simply remove it from our queue. So here in this case we'll remove 10. We'll remove 10 from our queue. Okay, cool. So okay, I'll just remove everything very quickly. I hope the logic makes sense till now. Okay, now what? Now my I is 1 and my j is 2, correct? Okay, perfect. Now here I won't I'll just write quickly the q values so that we don't have to do the computations again and again. So my I is 1 and j is 2. The minimum is 1 and the maximum is 2, right? So 2 minus 1 is 1, right? It satisfies the condition. So till now I am able to achieve a subarray of size 2. Okay, so my answer will be 2. Now I'll increase the j pointer here. Okay, now my I is 1 and j is 3. Okay, 4. So now my maximum is 4. Okay, and I'll also keep adding it. So since this is 4, this should be in increasing order, this should be in decreasing. So now this queue will look something like this. So now 1 minus 4. 1 minus 4, yeah, it satisfies the condition. Yes, it does. So I'll increase my answer variable size to 3 and I'll move forward. Cool. Now this is possible. Now let's try one. Now this. Now what's the biggest value? Again, now the biggest value is 7, right? The biggest value is 7. Now let's take the difference. Does it satisfies the condition? No, it doesn't, right? It doesn't. So till now, the maximum subarray I could have achieved is this, right? 1, 2 and 4. And this 7, as it doesn't satisfy the value, now what we will do? We'll increase our I pointer, right? We'll increase our I pointer. So now I becomes 2 and j becomes 4, right? I becomes 2 and j becomes 4. Let me change the color. 0, 1, 2, 3, 4 and j is here. Okay, now let's check. Okay, cool. Now the minimum value is 2. Oh yes, and by the way, yeah, after we are moving I pointer, we need to check if anything is equal. Here 1 was equal, so we have to remove it. So now the queue looks something like this. Cool. Does this satisfies the condition? Yes, it does. So now I'll move my j pointer. Okay, I'll move my j pointer as it satisfies the condition. 7 is I already appended. Now my j is here. Okay, it's on 2. Does it satisfies the condition? Yes, it does. It's already on, and it's already in the my queue. So now what? Now look, I got a array of a subarray of size 4. So my answer becomes 4. And now since I have reached the end of the array, this is it. Whatever is the maximum answer we have received, we will simply return it. I hope I was able to clarify the question properly and make you understand. Now let's go to the solution and try to code this out so that you have a better understanding. Okay, cool. So as discussed, what will we do first? Okay, we will let's declare our two increasing queue and decreasing queue. So I'll say increasing queue and a decreasing queue. I am using Python language. Please feel free to use any language of your choice because of course, understanding the logic is the main point here. Cool. I'll take two variables, I and j. Let's take n as length of nums. Okay. And I will also keep my answer variable as 0. And in the end I have to return answer. The logic goes here. Okay, so while j is less than n, okay, because we'll increase our j pointer. Now let's check. So while let's say my increasing queue is not empty, it exists, right? And my increasing queue, okay, the last element at increasing queue, right? If it's greater than my nums at j, it means that it's violating the increasing order. Okay, it's violating the increasing order. I'll simply do increasing queue dot pop. Okay, and once it's satisfied, the order is not violated, I'll append my nums at j. Cool. I'll do the same for the decreasing queue as well. So let's say in my decreasing queue exists and decreasing queue at -1, here it's less than nums at j, right? It shouldn't be less because of course now it has to go in a decreasing order. So what we will do a decreasing queue dot pop and once it's done, I'll just append the current numsat j to my decreasing queue. Okay, now how we are calculating our answer? We were calculating our answer as max of answer j minus I plus 1. Okay, this is the way how we used to calculate the length of the maximum subarray we have found. Okay, cool. Now we need to check that what if the window size is violating the amount of limit we are given. So if decreasing q at 0, the maximum element minus the minimum element in the subarray, right? If it's greater than limit, what we need to do? We'll just discard, and before discarding, we need to check that that element at I does not exist in any of our queues, either increasing or decreasing, right? So if decreasing q at 0 equals nums at I, right? We'll just do a pop left. Okay, same for decreasing. Oh, sorry, syntax error. Decreasing q dot pop left. Okay, I think it looks good. Now we can simply do I equals to I plus 1. And I think this should run. Let's try to run it. Cool. I think it's accepted. Yes, it's accepted. And yeah, that's the solution. Do let me know in the comments how you feel about it, and do like, share and subscribe our channel if you find our content useful. Thank you.